All right, welcome to the lesson 1.6 notes on describe angle pair relationships. We'll run through a little bit of vocab here, going through some specific types of angle pairs that we'll need to be able to recognize, understand what they mean, ultimately to find angle measures, to find unknown angle measures in these angle pair types of figures. So let's run through the vocab. Let's get that notes done. This is the notes portion that we would be adding to our notebook. First one. Maybe complementary angles. All right. So some of these terms, I would guess this is a term that a lot of us are familiar with. Everything again today is pairs. So we're talking two angles whose measures add up to 90 degrees. So really, the kind of couple ways we might see complementary angles would be just kind of individual angles hanging out here. I've got let's say maybe a 30 degree. Somehow we measured that, or we knew that was a 30 degree angle, and then somewhere else I've got a 60 degree angle in angle C. So we would, because of their sums, because of their measures adding up to 90 degrees, we could definitely say that, hey, angle B and angle C are complementary because their measures add up to 90. A little bit different a look would be maybe two angles. Let's start with a single angle first. Going back to the previous lesson, we should know that angle X would be best described as a right angle because of that little notation right here that says, hey, that's 90 degrees. So this angle by itself, we know its measure is 90. Not complementary because there's only a single angle, right? Everything today is pairs. So if I were to split, let's say, not necessarily even down the middle, but let's split this angle. If we can do it. If we can split this. Oh boy, there we go. We only need one of those. So split it into two different angles, angle 1 and angle 2, without necessarily knowing even what their angle measures are, right? Is this 10 and 80? I'm not sure, but I know that when I put them together, because of our angle addition postulate, it says this measure plus this measure of 2 has to come up, or has to sum to the measure of angle X. So there's maybe a different look where I know specific numbers in this case, or just understanding that the two angles are adding up to 90. Or their measures. Second one, so that's our first vocab word. Second vocab word, 5 to kind of get through, or 5 different angle pairs. So we're going to look here, and I don't want to go too far. Right there. Supplementary angles. They go hand in hand, right? If you learn about complementary, you probably had heard about supplementary. It's two angles whose measures add to 180 degrees this time. So similar idea where I could have kind of two separate angles, maybe 120 degree. And I'm not saying, obviously, that they all have to be 120 and, this one have to be 60 degrees. But any two angles, so again, we could say B and C, the angles B and C are supplementary because their measures, without a doubt, add up to 180 degrees. Also going back to the previous lesson, if I were to look at a straight angle, which we define as an angle whose measure is exactly 180 degrees, in other words, a line, right? But a line has a measure of 180 degrees. By itself, not supplementary. It's just a single angle. But like before, if I break this into two smaller angles, we could definitely say that angles 1 and 2 are supplementary because I know their measures have to add up to 180 because we're working with the straight angle from here to here. All right, so there's complementary, supplementary. Add them to your notebook. Let's just keep plugging away. Let's get the 5 vocab words done here for the lesson. Next one coming up is what's called adjacent angles. So adjacent angles are two angles that share a vertex and a side. We've actually drawn we've drawn this twice already today. So we've seen some examples of complementary and supplementary potentially being adjacent. Basically means I've got an angle, or I've got two angles, right? It's always a pair. I've said that like 4 times already. And they're sharing a vertex. We can call it a vertex X here. They're sharing a vertex and a side. So angle 1, what are its two sides? It's this, we can't really name them right now. Let's call it ray X, Y. It's supposed to be a capital Y. So ray X, Y is one of the sides of angle 1, and ray X, Z is its other side. All right. For angle 2, what are its two sides? Definitely XZ, and that's the overlapped one. And then let's come back to W. So ray XW. So they all have a separate side that they're not sharing, but both angles end up sharing this vertex and this side right here, which fits our definition, a common vertex and a common side. Two angles that are kind of right next to each other. Let's just look here and some non-adjacent angles. Sometimes it's helpful to see, because if I ask you in a figure to identify the adjacent angles, there's ones that are kind of trickier, ones that sometimes are mistaken for being adjacent when they're not. So let's look here. What if I give you an angle 1 and angle 2? Why are those not adjacent? They're sharing a side, definitely. Like this side is a common side for both of those, but the problem is angle 1's vertex is here and angle 2's vertex is there. They're not sharing a vertex, so we've only met one of their criteria. We could end up in a situation that maybe we're sharing a vertex. So I've got an angle here, angle 3, and then a different angle right here, angle 4. Are they adjacent? No. They're sharing a vertex, which is definitely part of it, but there's no shared sides. They each have their own individual sides. So there's some non-adjacent angles. Obviously, anything that's separate also would fall into, so angle 5 and angle 6 as just two separate angles. Definitely not adjacent. They're not sharing anything, not sharing a vertex, not sharing a side. So that's adjacent. Two more pairs to look at. Let's talk linear pair. Look at that. It's right in the name of it. So a linear pair, now that we've talked about what adjacent is, are adjacent angles that are supplementary. Non-common sides are opposite rays. Opposite rays. So as we look at it, again, it's one that we've drawn already. A linear pair, it's kind of in the root of the word there, needs to have a line involved. So this situation, let's sketch it and then kind of talk about it. Angles 1 and 2. All right, did we meet our criteria? Angles 1 and 2 are adjacent. They're sharing a vertex, yep. And they're sharing the side right here, the black colored side. So they're adjacent angles. Are they supplementary? Yep, going back to what we had talked about with supplementary is, although I don't know exactly their measures, I know that the measure from here to here on this straight angle is 180 degrees, and that was the definition of supplementary. So a linear pair has to be supplementary, and they have to be adjacent. So there's really only one kind of figure that fits that bill. Common ones we'll see, though, and sometimes confusing, would be something like this. Now I've just got intersecting lines, and by doing that, we've created 4 different angles, and I say, hey, what are all the linear pairs on the board right now? Well, angles 1 and 2, just like we talked about, but then I also have 1 and 3. I also have 2 and 4, and I also have 3 and 4. So you got to kind of picture, we can't always just look at the top part and say, oh, yep, that's 180 degrees from there to there. That's absolutely true. But this exact same figure could, let's see if we can do this, get rotated and just kind of just to try to picture it a different way and say, oops, I was hoping I could get the angles to come with me. And say that, all right, if I look at it like this and kind of put the line, yep, now 2 and 4 are a linear pair. Turn it all the way over. Now 3 and 4. So we're not changing anything. We're just kind of changing our perspective on it. 1 and 3 are also all linear pairs. So in a figure like that, let's put it back to how we started. We end up with 4 different pairs of linear pairs. So another good look at some mix-ups, some change-ups as far as things that we'll see. All right, last vocab word here is vertical angles. A pair of angles, or vertical angles are 2 angles whose sides form opposite rays. I think that's a good, nice, short definition, but the problem is if you're not super strong with what opposite rays are, that might not mean a whole lot to us. Okay. For this one, I'm going to add kind of a follow-up note. Think the letter X or T even, which we kind of just looked at a second ago. I need to see the letter X. So if I kind of draw that same picture we were just looking at and number these 4 angles, 1, 2, 3, 4, and I said, hey, there's linear pairs up there, 1 and 2, 2 and 4, 3 and 4, 1 and 3. We just got done talking about that. We've also have vertical angles. So angles 2 and angle 3 would be an example of vertical angles. So one on this side of the X and one on this side of the X. So they're kind of on opposite sides. How does that meet this definition? What's going on with these opposite rays here? So just to kind of make sure that that definition makes sense, where's angle 2? It's right here. It's got its sides. I'm going to highlight in pink. And then let's highlight angle 3's sides in green. So if I look at the sides, this side right here, the pink and the green, that's a good example of opposite rays. They got the same endpoint, but one goes forever this way, and one goes forever this way. So that's an example of that being an opposite ray. Same thing happening here. So I know it's a real technical definition, and you got to know what an opposite ray is, but I've got a pink ray headed this way, and I've got a green ray headed this way. They're all sharing the same endpoint. So it does fit our definition. I think it's maybe a little bit more helpful to think of it as the letter X. I need to see the letter X to have vertical angles. Common maybe trap problems that we might see as far as identify the vertical angles. Well, what letter did I just draw? It's not an X, that's a K. And if I were to number these different angles here, 1, 2, and 3, and I said identify the vertical angles in that picture, a lot of people would maybe say 1 and 3. They kind of almost have that feel of being opposite of each other. We should also add for this figure over here that we also have angles 1 and 4 being vertical angles. But on ours, we don't really have that going on. I don't have that X, those intersecting lines crossing. So we wouldn't be able to really say anything for this one as far as having vertical angles. And also linear pair would be off the table too, because although the measure of angle 1, 2, and 3 does add up to 180, and they form a straight line right here, a linear pair by definition has to be made up of 2 angles, where here we're talking about 3. Okay? So that's our vocab, our new vocab, our angle pairs for the lesson. Let's run through just one last thing. We definitely touched on this here as far as we covered it with our examples. Complementary could be adjacent, non-adjacent. We talked about that when we were taking the notes. Same thing with supplementary. We could have adjacent, non-adjacent, supplementary angles. So I think we talked about that. No need to add anything new for that section. Last thing we got to run through is, what are we going to do? How are we going to work with these new concepts? So first one, example 1, in the figure, name a pair of complementary angles. Let's stop at that. All right, what are the complementary angles in this figure? Are there any? Hopefully there's some. So complementary angles. This one's one that I don't see any right angles, so I can't really go down that road of assuming, this is 90. It tells me it's 52. So I think we're going to work with the angle measures. So I'm looking for 2 angles whose measures add up to 90. So if I take the 52 plus 38, I'm seeing that as, okay, that's 80. Yeah, 90. All right. So going back again to the last lesson is, how do I talk about this angle right here and this angle right here? I can definitely call this one angle B. So angle B. Now down here, I definitely don't want to say angle D, because there's several angle Ds here. Are we talking about this angle D? Are we talking about this angle D, or the whole big angle D? So I definitely need to use the 3-letter method for naming this angle. So I'm going to say angle CDB as far as my 2 angles. Okay, so there's a good look of name a pair of complementary angles. Second question is asking for a pair of supplementary. So I'm just kind of abbreviating here, maybe clearing off some of this stuff. All right, so now I'm looking for two numbers, essentially. Again, I don't see any lines, any linear pairs. If I had a linear pair, that would be a good option as far as going with supplementary. So I think I'm going to have to work with measures again. And if I take the 52 plus 128, yeah, we're summing up to 180 degrees. So I need to talk about this angle right here and this angle right here. So I think we can stick with that same technique of just calling this first one angle B. But now we're talking about this angle over here, which is angle BDE. Remember, that could also be named EDB as well. We're talking about that same angle. All right, last one, or the last direction, said to identify a pair of adjacent angles. So remember that sharing a vertex, sharing a side, adjacent. Let's see what we got here. I think we're talking about this angle right here because this vertex is common to this angle, and they're also sharing, where did I get my overlap? Right here. So I end up with angle BDC and angle BDE as adjacent. So there's a good illustration of how I might ask you, how I would check your understanding of the vocab. Good example. Next one. Given that angle 1 is a complement of 2 and measure of angle 2 is 57 degrees, find the measure of angle 1. Okay. The reason I left this one on here, I think that's a very hopefully doable question. I don't know if we necessarily need a picture. I just wanted to see, we talked about specifically the word complementary. Any form of that word. So complement is definitely the root word of that. So if I asked you if I told you that two angles, one was an angle, was a complement of the other, that's still a way of referring to or implying, not implying, but telling us that these two angles should sum up to 90 degrees. Okay, so it's really a matter of, all right, well, measure of angle 1 plus the measure of angle 2 should equal 90. That word complement told me that. We know that the measure of angle 2 was 57, just from the given information. And then the measure of angle 1 is what we're looking for. So we'd end up subtracting the 57 from both sides. I don't necessarily expect us to set up a big formal equation like this. I understand a lot of us see that and hear, hey, complementary complement, I can go 90 minus 57, just kind of right off the bat and just say, hey, the measure of angle 1. But again, let's do this right with notation. I was stressing it on the last problem as far as naming the angles correctly. Same idea here. Let's not just throw a random number 33 out, just hanging out. I need units on it in degrees. And I should be saying, what did we find? We found that the measure of angle 1 was equal to 33 degrees. Very, very, very similar concept with 3. Same thing. It's just the root of the word supplement or of supplementary. We're just talking, say, hey, it's just a different way to phrase it. That given that angle 3 is a supplement of angle 4 and the measure of angle 4 was 41, find the measure of angle 3. So here's one. Hopefully you're following the logic there on that I can take just 180 degrees, subtract off that 41, the 41 that we were given, and say that the measure of angle 3 has to be 139 degrees to get us to that 180 mark. All right. So kind of a short, sweet example there. Nothing, I don't think, too strenuous. Keep it moving. A couple left. A little bit of a situational one. It's nice they're giving us a figure here. The basketball forms a pair of supplementary angles with the ground. Find the measure of angle BCA. So we're looking for both of these individual, and then angle DCA. So looking for the actual true measure of both of these angles here and here. I think a better name for this here forms a pair of supplementary angles with the ground. We could shorten that whole statement up and said the basketball pole forms a linear pair with the ground, a pair of supplementary angles with the ground. Either way, that's more of just a terminology thing. I think the situation here is I've got this linear pair, and I know from here to here, this straight angle measures 180 degrees. So there's a number still going on here that we don't technically see. It's not explicitly stated, hey, use 180 degrees. That's going back another time to our previous lesson and saying a straight angle, which is right here, measures 180 degrees. That's where I'm getting that other number from. Okay, so we can take the 3x plus 8 and then using that angle addition postulate, add it to the 4x minus 3, which represent these are expressions for our two angle measures. When I add those two together, I know I should be getting 180 degrees. So there's our algebraic setup as far as how we're going to approach this problem. Let's combine some terms here. 3x and 4x is a 7x. Whoops, why am I writing 4? 7x. And then I think right along with it, I'm going to combine my 8 minus 3 and get 5. Equals our 180. We'll tack the degrees on at the end. I'll subtract a 5 from both sides to get 7x equals 175, and then divide 175 by 7 to get x equals 25. All right, like a lot of ones that we've been doing, Make sure we finish the problem. All right. So I feel comfortable with my solve here. X equals 25. I just need to make sure now that I answer the question. So the first one it asked us for was, what is the measure of angle BCA? So I'm going to take this 25 and find BCA and plug it in right here. Maybe we can do this one without a calculator. 3 times 25 is 75. And then we'll go 75 plus 8, which is 83 degrees. Okay, I know I'm not showing my work on that one. I'm kind of talking through it, but hopefully we follow there. Last one, I have a couple different ways of actually finding what's our last thing we're looking for, the measure of angle DCA. I would probably just take 180 minus 83. I could also bring this all the way over here, and maybe it is easier to do without a calculator. 180 minus 83 isn't as easy in my head as maybe 25 times 4, which is 100. All right, 25 times 4, first thing I'm doing is 100, and then 100 minus 3 is 97. So however you get there, I think that's what we should end up. I got a quick confirmation. Does 83 plus 97, if I wanted to check it, yep, that sums up to 180 degrees, which is what we thought we should have had initially. All right. A couple more. You can kind of just see it. It's the lesson is, once we learn the vocab, is let's apply it in the sense of maybe in the directions, find a pair of supplementary angles with the ground. Here's a good look at one where it's asking us to actually just go through, hey, did you learn that vocab? Identify all of the linear pairs and vertical angles in the figure at right. So let's start with linear pairs. Linear pairs. Do we have any, right? A linear pair. If I don't remember what that is, I'd flip back in my notes. I'll do just a little mini picture of what we made before. I'm looking for a pair of angles whose non-adjacent sides form that straight line. I definitely think we've got it going on here from 1 and 2, from angles 1 and 2. Angle 1 and angle 2. So it's kind of nice, shorten it up a little bit. I also think this is one of those ones that if we rotate the paper, if we need to, but I think I can see it here without that, from angle 2 and 3 when I get put together are also forming another line. So angle 2 and angle 3. The one that sometimes people, and I think we talked about it when we were first doing the note, was what about from here to here? Well, that's definitely adds up to 180 degrees, but the problem is we're talking about 1, 2, 3 different angles, which does not meet that definition of being a pair of angles. That's 3 versus 2. Did we get them all? I think so. I think that's all our our linear pairs. The vertical is what we'll do next. So let's do that one. Let's talk all of the vertical angles. So vertical angles. Let's take a look. Maybe clear this off here. So remember, what are we thinking when we're thinking vertical angles? We want to be thinking of that letter X or T, where they form that. You get kind of that 4 sets of angles. Now we have some of that going on here. The problem is this little line, or this ray right here, is messing things up from our perfect T or our perfect X. So sometimes people will actually go over and just, where is the actual X or where is the T going on here? This line right here and this line right here are forming that X. So where are my opposite sides, or my opposite side? That's kind of a loose term. It's definitely not sides, but the opposite angles would be like angle 1 and angle 3. They're in the different compartments, different quadrants, whatever you want to call it. So definitely, I think we want to say angle 1 and angle 3. Now, the problem with this particular one, yes, there does exist this other pair, this angle 2, with this group of angles over here, but that group is split into 2. So you could argue that, well, Mr. Crow, could I switch this to 6 and say that angle 2 and angle 6 form a pair of vertical angles? Yes, that's 100% true, but that was something that we had to add. So I would say if the figure looked like this initially, the only 2 that we could actually name and identify without adding extra information would be angles 1 and 3. So there's a look, just straight vocab. Do I recognize what a linear pair is? Do I recognize what a vertical angle is? All right, last one. Last example, last part of the notes. Oh, no picture for this one. So let's see what we got. 2 angles form a linear pair. the measure of one angle is 4 times the measure of the other. Find the measure of each angle. All right, here's the key piece. Linear pair, again, it's a vocab word. We got to be comfortable with those 5 terms. A linear pair, I know, based on what we just talked about with the notes of definition of a linear pair, and even in the last example, should look like this. I need a line, and I need to split it. How did I know to split it right there? I didn't. I could have split it and drawn it, more like this or more like this. Sure, I could have drawn it either way. I just really need. I'm looking for a place to kind of hold some of our values here. All right, because again, like we've seen earlier, there's an implied value, or not an implied, but an actual value there of 180 degrees that we can use. All right, so for us, where's the other piece of information? The measure of one angle is 4 times the measure of the other. So I don't know actually what either one is, but I think we can help ourselves out and say, if I just happen to call this angle X, I don't know what it is. I have no idea what its value, but if that one's X, the other angle that's forming this linear pair has to be 4 times that value. So there's algebraically how we could represent that other angle. Bringing that together with our 180, it ends up almost being just like the basketball problem. That the measure of angle 1, which we're calling X, plus the measure of angle 2, which we've called 4X, has to add up to 180 degrees because of this linear pair. So the work for this particular one ends up being not too bad. You combine our like terms, 5x equals 180, and divide both sides by 5, we get x equals 36. And because that was actually one of the angle measures, we didn't define and say angle 1 or whatever, but find the measure of each angle, just the way we laid it out here. The measure of angle 1 has to be 36 degrees. Now you could have called it measure A or B or whatever, however you made your picture maybe. And then the second one, I'm just taking my 36 times 4 to figure out that the measure of angle 2 equals 144. So have we met both criteria? Absolutely. One is 4 times the size of the other, and they both angles, or the angles when put together, are supplementary. They form a linear pair. So there's just a couple different looks. Are there other ones? Sure. Different things we might see on the assignment. So give it a great effort. Let's go back and just double check that we hit our goals. Really, it was just kind of the one big goal for the day is use these 5 vocab words for the 5 angle pairs that we talked about today to find angle measures. And that's kind of what we were doing, finding different angle measures throughout the given figures. So there's your lesson 1.6 notes. I will see you in future lessons.